this is our part 2 in simplifying radical expressions. So if we here we see our square root sign or our radical sign, and underneath this time we have a fraction, 2/72. The first thing we want to do is see if we can simplify anything underneath the radical sign. We can simplify the fraction 2/72 by dividing both the numerator and the denominator by 2. When we do that, underneath the radical sign, we have the simplified fraction of 1/36. Now we see if we can take the square root of either or both the numerator and the denominator. So we can break it down separately and ask what is the square root of 1 on top, what is the square root of 36 on the bottom, and that gives us a fraction of 1/6. Again, we have a fraction here, and we ask ourselves, can we simplify the fraction 256 divided by 4? Well, 256 divided by 4 happens to be 64. Now we know that 64 is a perfect square, so we take the square root of 64, which is 8. If you have more than one operation underneath the radical sign, we need to do our order of operations, our PEMDAS, and get it down to one number. So underneath here you see 3 squared plus 42, and according to order of operations we would have to do the exponent first. So we're going to do 3 squared first, which is 9. That gives us 9 plus 42. That is supposed to be 4 squared. This is supposed to be squared. It didn't work on my PowerPoint. 3 squared plus 4 squared, so we're going to do both exponents first. 3 squared is 9, and 4 squared is 16. Now we have 9 plus 16, which is 25, which happens to be a perfect square, and the square root of 25 is 5. Here we have 5 squared plus 144. Again, we're going to do the exponent first. So 5 squared is 25, and 25 plus 144 is 169, which happens to be a perfect square, and the square root of 169 is 13. In this, we have a trinomial. We're going to factor it first, and the answer is going to be the absolute value. Now, we can remember our perfect square trinomials. Remember, when we see something like this, we can look at the a term. Can we take the square root of x squared, which is x? Can we take the square root of the c term, which is 4? And we can check to see if it's a perfect square trinomial by multiplying 4 times x, which is 4x, and then doubling it. And if you get this middle term, we know it's a perfect square trinomial. So to factor it, it's just x plus 4 squared. If you can't remember how to do that, you can do the reverse FOIL, where you think of factor pairs for 16, and you find the 2 factor pairs that add together to get the middle term, which is 4. So you would have x plus 4 times x plus 4, which is the same thing here. Now, to take the square root of something being squared, the signs basically cancel each other out. So to take the square root of something being squared, you just have x plus 4. But it's going to be the absolute value of that, because two numbers, you can either have 2 positives or you can have 2 negatives. Now, when you have something underneath like this, and it's not a perfect square, you want to see if you can find a factor pair or factor pairs that where one of them is a perfect square. Well, with 18, I have 1 times 18, and 2 times 9, and 3 times 6. But right here, I know that 9 is a perfect square. So if I divide this into the square root of 2 times the square root of 9, which is equal to the square root of 18. I've just factored it out. Now I can take the square root of 9, which is 3. So we put the 3 outside of the radical sign because we took the square root of 9. The 2 is not a perfect square, so we leave it underneath. So the answer would be 3 times the square root of 2. 128 is not a perfect square, but I do know that the factor pairs 2 times 64 is equal to 128, and 64 is the highest perfect square that I can get. I can take the square root of 64, which is 8, so I have 8 times the square root of 2 left over. And we're just going to leave the answer like that. If it's not a perfect square, we're just going to leave it under the radical sign. When you have variables with exponents, if they are even, to take the square root of it, you just have to half it. So what we have here is we have x to the 4th power. I'm going to break it down to x to the 2nd power, x to the 2nd power, y to the 2nd power, and y to the 1st power. Now right here, I still have x to the 4th power. I just divided it into 2 pairs. Here I still have y to the 3rd power. I just broke it into 2 and 1, because if I have an even number, the square root of x squared is x, and the square root of x squared is x. So when you take the square root of x to the 4th power, you just have to halve the exponent. So the square root of that would be x squared, as shown right here. I can take the square root of x squared, which is y, but that leaves one y underneath the radical sign that I can't take the square root of it. So if it's an even exponent, just half it to take the square root of it. If it's odd, you're going to have one left over, and then whatever's, after you take that one out, the even number that you have, you just half it, and that comes outside. So our final answer is x squared y times the square root of y. I can take the square root of x4, x squared y times the square root of y. Okay, here we have x cubed, so if we break that into x squared, we can take the square root of x squared, which is just x. That leaves one x underneath the radical sign. We can take the square root of y squared, which is y. It's gone away, so our final answer is just xy times the square root of x. Here we have 3 bases. We have the square root of 48, we have the square root of x squared, and we have the square root of b. Let's take each base separately. 48 is not a perfect square, but when I think of the factor pairs for 48, 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Which one of these has a perfect square? We have 3 and 16. So we can break this into the square root of 3 times the square root of 16. I can take the square root of 16, which is 4. So now I have 4, and I have the square root of 3 still underneath. I can take the square root of x squared, that would be x, so it comes outside. b is not a perfect square, so it stays underneath. So I took the square root of each one separately. If I take the square root, it goes on the outside. If I don't, it stays underneath. This one is on number 3 on Workbook page 182 if you're looking at it. How do we do larger numbers? You could multiply 24 times 140 and then try to find factor pairs for that, but the bigger the numbers get, the harder it is. So in this example, what I would do is I would take 24 and I would think, okay, what factor pairs do I know for 24, and is one of them a perfect square? We have only one that has a perfect square number, which is 4. So I'm going to break this into the square root of 4 times the square root of 6. I can take the square root of 4, which is 2. So that gives me 2 square root of 6. 140, when I do the factor pairs for it, I find that one of them is 4 times 35. So I can break this down, 140, break it into the square root of 4 times the square root of 35. I can take the square root of 4, which is 2. So now I have 2 times the square root of 35. We haven't done this in a lesson yet, but when you get to this point, you can multiply what's outside together. 2 times 2 is 4. And you can multiply what's underneath together. And 35 times 6 would be 210. So here's our final simplified answer. It gets a little longer and it just takes practice. I hope this helps with simplifying radical expressions.